Good morning, my dear students. So coming to the next experiment, that is the next experiment name is circular polariscope. Okay, so the aim of this experiment is what? To calibrate the given photoelastic specimen and to find the difference of principal stresses of a circular disc subjected to a diametrical or pure compression. Okay, so here we are going to use a photoelastic material. Okay, so that component we are going to fix on the circular polariscope experiment. If you apply the some compression force, you are going to get a number of different fringes depending upon the given load. Okay, that need to find. Okay, that we are going to take the values and find out the finally principal sizes of the given photoelastic circular disc. Okay, so here apparatus is what? Circular polariscope specimen is required. Okay, so here for your syllabus there are two will be there, plain and circular, but we are going to use here circular polariscope. Okay, so the here because of if you want to study this experiment, you need to have a knowledge about the photoelastic effect. Okay, so here what the photoelastic method depends upon the property of the certain transparent solid by which the become a duly refractive under the action of different stresses. Okay, when if you are going to apply some forces on that particular photoelastic specimen, you are going to that value become what that there will be a chance of producing a stresses in that particular component. Okay, the magnitude of the optical effect bearing the definite relation to that of the stresses. Okay, this optical phenomenon is an optical instrument containing a polarizer to utilize the property of the polarized light in the operation. There are two different types of namely plain polariscope and circular polariscope. Okay, so in the polariscope experiment you are going to use the sodium vapor light. Okay, so when if you switch on that light, you are going to get a number of fringes in a circular polariscope that is photoelastic specimen when you are subjected to a compression experiment. Okay, so that we are going to you are going to see that videos that also how we are going to get the number of fringes. It is similar to the rainbow. Okay, so different color we are going to observe in the photoelastic specimen. Okay, so how we are going to conduct the experiment means first you switch on the polarized to the polarizer light. Okay, that is circular light. Okay, this circular light we are going to call as a sodium vapor light. Okay, that light is different, that is not like a normal light. Okay, so switch on the sodium vapor lamp having that experiment, that lamp is called as a sodium vapor lamp, hence you are going to get a sodium vapor light. Okay, so wavelength that is also called as a monochromatic light. Okay, so wait 5 to 10 minutes till you are going to get some different color of that is what golden yellow color light is going to obtain. Okay, so just you wait 5 once you, after switching on the sodium vapor lamp, just you wait for 5 to 10 minutes. Okay, so load the specimen disc gradually and count the number of fringes to its point of the interaction. Okay, so now you keep the photoelastic specimen on that particular polarized circular polariscope set of experiment, then you apply the load 1 kg 2 kg. Okay, so at 2 kg note down the number of fringes how much they are going to get. Okay, so to check the for the fraction fringes, rotate in the viewing mirror clockwise until the inner fringe form the shape of figure. Okay, of 8 numbers. Okay, so so beginning is 1 to 8 number, you are going to get the number of fringes in the photoelastic specimen. Okay, so note down all the angle data that note down the angle theta and find the number of fringes using the relation n1 plus n plus 180 where n1 2 3 4. Okay, so this is the formula to calculate the n1. Okay, repeat the same experiment with a different loads. Okay, repeat load, that is what repeat the different procedure with a different load. Okay, and plot the effective load versus number of fringe. You are going to get the pn, that pn values you are going to calculate the values. Okay, so this is the graph you need to draw. So load here and number of fringes occur, you are going to get the mean here. Okay, so this value you need to calculate. So this is a circular polariscope. Okay, so here this is what circular polariscope experiment. So this is a what monochromatic light. Okay, so when if you switch on this, so in between these two you keep the photoelastic specimen. Okay, that we are going to show you in the videos also. Okay, we are going to in the live also. Okay, so keep here, and at the right hand here we are going to substitute the what here going to substitute the load, or each here going to add one load here. Okay, for 1 kg of load you will observe here, look at here your eyes close to eyes from this light. Okay, so here you are going to get the number of fringes on that photoelastic specimen. Okay, again for second load, third load, that like that you have to remember that like that you have to do the experiment. Okay, so that this is called as a circular polariscope photoelastic specimen. Okay, so like that you are going to get the, you are going to observe the number of fringes in the circular polariscope like this. Okay, so here the circular so the diameter is given, you note on the initial diameter whatever it is. Okay, so this is a tabular column. Okay, so load at 1 kg, so convert 9.81, so it is the effective load. Okay, so suppose 1 kg 9.81, note down here effective load, number of fringes occur, what are the number of fringes occur in that this circular polariscope, that you note down here. Okay, with the help of values. Okay, so here you need to calculate the principal stresses and principal stresses for practical and theoretical. Here spelling is mistake is there, practical and theoretical. Okay, So here the observation is given, diameter of the specimen is 60 and the thickness of the specimen is given t is equal to 5 mm, and the distance from the fulcrum to the applied load, that is the length, is given 1150 mm, and the distance from the fulcrum to the center of the specimen, that is L2, is equal to 380 mm, and the material of the fringe constant you need to calculate. Okay, so at for here we are going to, if you are going to take the 1 to 5 means take any one, the lowest value or highest value for at what for third kg of load, what is the principal stress and theoretical stress, that you know down here. Okay, so like this you need to do the calculation part. Okay, this is just I'm going to hint you the, so third session we are going to take the how we are going to take the values. Okay, the calculation part we are going to explain you. Okay, so I hope you understand this circular polariscope experiment. Okay, so okay, thank you. Good morning, my dear students. Today I am going to conduct the last experiment, that is a circular polariscope. Okay, this experiment comes under part B. So here what we are going to find here, nothing but you are take a circular okay photo specimen component. So here how many number of fringes are occur in this element with the help of this circular polariscope setup. Okay, that we need to find here. Okay, finally we are going to find out the this photoelastic material principal stress and okay na. So here the aim of the experiment is to calibrate the given photoelastic specimen and find the difference of principal stresses using this circular polariscope setup. Okay, now I will already I told you before going to this experiment, I already told you in the first part, that is what you mean by the photoelastic theory and what is the mean by this circular polariscope, this what the different types of specimens we are going to use to conduct this experiment. Okay, so here for our exam, for your syllabus, we are going to conduct what two specimen. One is a circular disc. Okay, so here we are going to apply some compression force. How many number of fringes occur in this element, that you need to take from this experiment. Okay, so this is about the circular polariscope. Along with this, you need to calculate also with the plane photoelastic specimen. Okay, so here, so as per, if you consider with your syllabus, there are two specimen you need to calculate. One is a plane component and second one is a circular polariscope. Okay, so today for today class we are going to take this circular polariscope and finding the number of fringes on this. Okay, so how I am going to take the readings on this whole setup, now today I am going to explain you. Okay, so this is about the circular polariscope setup. Okay, this is called as an analyzer. Okay, the modified the component we are going to observe in this by using rotation up. Okay, so if you observe the new modified component by okay, so you can rotate this component, we are going to calculate the number of fringes, but we are going to observe here in this experiment. Okay, so now what I am going to do is so now how to take the reading. Okay, first you want what you want to do is switch on the current of this circular polariscope setup. Okay, so here I am going to set up. Okay, once if you on this this light is called as sodium vapor light. Okay, so that is called as monochromatic light. Okay, so here on this monochromatic light we are going to find out this number of fringes. Okay, now what I am going to do is take this photoelastic specimen. This is circular disc. Okay, so just you keep this. Okay, so this length is called as a fulcrum length. Okay, so that very important. Okay, this length is given in the observation, already I explained you. Okay, this is called as a fulcrum length. This is called as an analyzer. What going to light which is coming, that is called as a sodium vapor light. Okay, now I am keeping the circular photoelastic specimen in this. Okay, exactly you fix in the middle. Okay, once if you fix on this, this is a circular disc. Okay, now you are going to apply a force on this element. Okay, with the help of some, if you use this some load. Okay, so here all we are having a 5 kg load, each load having 1 kg. Okay, so if you apply here, okay, so first you fix this specimen, that is called as a photoelastic specimen. Okay, this is circular. Okay, so once if you fix properly here, then you apply compression force, that is compression force. Okay, with the help of this load. Okay, first if you keep, so 1 kg of load. Okay, so keep here in this. Okay, so be carefully, it will fall on your leg also. So if you apply your 1 kg of load, now you observe the here, now you observe the this number of fringes through this analyzer. Okay, if you observe means you are going to get some dotted, the dome shaped number of fringes, but if you at 1 kg of load, it is not coming properly. Okay, so now if you otherwise better you can switch on the light. Okay, now so take again 2nd kg of load. Okay, just you hang on this side. Okay, so if you at 2 kg of load, you observe the number of fringes occur in this through analyzer. Okay, so here we are going to get the 2 number of fringes on this photoelastic specimen, that is a dome shaped. Okay, it is like a rainbow color. Okay, so just you observe also, you are going to get. Okay, so 2 dome shaped fringes are we are going to get at 2 kg of load. Okay, that you note down in the tabular column. Okay, at 2 kg of load, the number of fringes on the circular polariscope is what? Circular polariscope, you are going to get the 2. Okay, so again similarly, again if you keep the 3 kg of load, okay, at 3 kg of load, so you are just to hang here at 3 kg of load, again you have to observe here through circular polariscope, you are going to get the 3 number of fringes. Okay, so at 2 kg 2 number of fringes you are going to get, at 3 kg you are going to get 3, again 4 kg of load. Okay, so 4 kg of load, if you keep it here, okay, again you see here through analyzer you are going to get the number of fringes are 4. Okay, so like this you have to repeat this experiment 2 3 4 5 readings. Okay, so take here, note down in the tabular column, and 1 kg of load, what is the number of fringes. Okay, so that you note down the tabular column. So remaining part I am going to explain you in the next. Okay, how we are going to calculate the principal stresses. Okay, formula. So here we are going to calculate the theoretical and practical. Okay, so theoretical stresses you need to calculate here, that is what? Principal stress sigma 1 minus sigma 2, and theoretical also you calculate with the help of some formulas I given in the tabular column. Then you compare, you are going to get the number of fringes. Okay, so here you need to plot the load versus, so you need to calculate the fringe material values. Okay, that you need to calculate from the graph. Okay, that also I will explain in the third part. So from this experiment, what you understand means how to take the reading from this circular polariscope setup. Okay, just keep the 1 kg of load, observe the number of fringes occur in this. Okay, repeat this experiment up to 3 kg. Okay, 2 kg what is the value, 3 kg what is the number of fringes, and 4 kg what is the value. Okay, in the third session I will explain how to take the graph, how to draw the plot, how to calculate the principal stresses and principal strain. Okay, that is what not principal strain, principal stresses. Okay, so I hope you understand this how to take the reading with the help of this circular polariscope experiment. Okay, so we will see in the next third video, we will tell about the how to calculate the number of principal stresses and principal strain, theoretical versus practical. Okay, thank you very much. Thank you. So after taking the values from the circular polariscope experiment, that is the number of load and the fringes, now we are going to come to the last session, that is how we are going to do the calculation part. Okay, so this is initially they given the observation. Okay, diameter of the specimen is given 60 mm. Okay, and the thickness of the given specimen is they given 5 mm, and the length fulcrum and the 1150, and the L2 length is equal to 380 mm they given. Okay, so these are the given values, that is the observation. With help of these values you need to calculate the principal stresses for theoretical and practical stress. Okay, so this is a tabular column. So load we are going to apply here 3 kg, 6 kg, 9 kg. Okay, so at 3 kg, so into 9.81, so if you multiply this, we are going to get this 29.43 Newton and 58.86 and 88.29. Okay, so kg you convert into Newton. So actual load so here L1 by L2 into this load, you are going to get this values. Okay, N is equal to 29.43, L1 by L2, this 115 by this into, you are going to get this 89.06, 178.13 and 267.193. Okay, so at this load you are going to get the number of fringes in the experiment circular polariscope experiment is equal to 2, and for the 6 kg, so you are going to get the number of fringes 3, and the 9 kg you are going to get the number of fringes 4. Okay, so here stress minus sigma 1 minus sigma 2 need to calculate, and sigma 1 minus sigma 2 theoretical and practical you need to calculate. So what is how to we are going to calculate? This is a formula is there. So 8 into 89.06 divided by pi into that is pi into 60 into 0. That is what 8 into 89.06 whole divided by pi into 60 into 5. So you are going to get 0.755 Newton per mm square stress formula. Okay, for this is theoretical values. Once you take this 89 point and this and this, okay, so you are going to get these values 0.775, 1.517, 3.368. okay, so initially I wrote the formula how it is going to get, that is okay 8. So here what is mean by 8? So here is a number of fringes 89 whole divided by pi d square. Okay, diameter is given 5, 60 into 5. Okay, so that you need to find here. Okay, number of stress one formula. Okay, I given in the formula I given, okay, thickness of the pi d square. Okay, stress is equal to pi load whole d square. Okay, that you apply the formula. Otherwise you note on the form before this formula I mentioned here, formula take the formula substitute here. Okay, so okay, so here the number of how that is a theoretical. Okay, this is about the theoretical. So along with that you have to plot the actual load. So here you substitute draw xy line. So actual load is equal 10 to 100. So here number of fringes we are going to get the 6. Okay, so plot the line at 2 fringes, you mark the at what load, at we are going to get only 3. So this point, this point, this point. Okay, so here at 2 29.3 and 358 and 488, that you notation you draw here, and take the slope. You are going to get 30 by 1 p by n, that is 30. Okay, p by n is equal to 30. This is what we got from the graph. Okay, so fn is equal to 8 pi d by p by n. Okay, substitute here, you are going to get the fringe material is equal to 1.273 newton. Okay, so theoretical is equal to what, this n, what you calculate from this n, so that you have to substitute here. So say experimental sigma 1 minus sigma 2 is equal to fringe material into n by t. So t thickness is given 5, fringe material is 1.273, so number of fringes is equal to 2 3 4. So you are going to get the values like 0.05092, 0.7638, 1.018. okay, so like this you have to do the calculation part. Okay, for the circular polariscope experiment. Okay, so for you compare theoretical versus experimental, take for one particular kg, you write the result. Okay, so this is how we are going to solve the calculation part in the what circular polariscope. Okay, so I hope you understand this calculation part. Okay, so thank you.